All right, so now we have the properties of real numbers here: commutative, associative, and distributive. I am not going to quiz you guys on which one is which, and most of these you kind of already have the gut feel for because you've been dealing with numbers most of your life. So commutative is like commuting. When we commute to work, we change where we are. We go from one place to another place. That's what happens with the commutative property. The order of things switches. So with addition, if I'm adding two numbers, I can add them in either direction as long as I'm careful about that minus sign being moved. So that negative 12 plus 39 is the same as 39 plus negative 12. I'm not trying to cross it off. I'm trying to highlight how it got moved. But I could write that as 39 minus 12 now. Adding the opposite is the same as subtraction. But on the calculator, you can also crunch plus negative 12 and it still works. Multiplication, same thing. The order we multiply things in doesn't matter. So that's why earlier I was saying if we had 5BA, it's the same as AB. This is the property that says that. Then we have associative properties, and these all have to do with parentheses. So what this is really about is the order you combine them. The order you add numbers in does not matter. The order you multiply numbers in or variables does not matter. So I can choose whatever order I want, whichever way is convenient. All right, so the first one, they move places. The second one, we change the order we're going to perform it in. But the associating is like the little parentheses are grouping things together, so they're associated together. That's why the word is being used. And then distributive combines the two. So the distributive properties of multiplication or over addition, and we usually shorten that to just the distributive property or distribute as a verb. So if I have something outside the parentheses, and then I have two or more things being added or subtracted in the parentheses, I can take the thing being multiplied and distribute through to everything on the inside. This works backwards as well, though, but it's harder to see working backwards. Like that's the one that's weird. It's kind of weird to explain even, but like for some teachers, I'm saying if it was one of those things that you hated, it's not the easiest thing to explain for some people. So the -7 times, and a lot of times we won't even put that dot there because remember, we're lazy. Mathematicians are lazy, so they wouldn't put the dot. So -7 smushed on to 19 plus 2x is multiplying, and then everybody gets one. So it's just like Oprah. You'll get a -7. You'll get a -7. Everybody gets a -7. Man, commenting about Oprah is probably out of date. I'm old. Either way, though, once you distribute, then you can actually perform the operation. -7 times 19 is something I can crunch. -7 times 2x, what is actually going on is instead of the 2x being in parentheses, we reassociate. So the -7 and the 2 get multiplied, and then -7 times 2 is -14. And so that's how we have the -133 and then minus 14x. All right, but we'll go with that backwards too, and we'll practice that. Just single terms though, not, although if you get comfortable with this, that is what factoring like quadratics does. All right, so apply the commutative property of addition or multiplication to rewrite each expression. This is boring. I mean, yes, math, let's do the math. All right, so -m times x. Flip the things. Arguably, you could write -xm, but the way they write this, they think like, I'm assuming they're going to say the negative is attached to the m. So then if we rearranged it, it would be x first and -m second. You have to have the parentheses, otherwise it looks like x minus m, which is not the same. Now, a minus 7, I can swap these, but the negative sign has to stay with what it's got. All right, so that 7 is negative, not the a. If a was 10, I'd do 10 minus 7, I'd get 3. But if I just swapped them and said 7 minus a, 7 minus 10 is not 3, it's negative 3. So subtraction is not the same forwards and backwards. But if you find yourself wanting to move it around, this is the same as a plus negative 7. Now that I have the addition, those I can swap. So it is also the same as negative 7 plus a. So it might be maybe there were more terms. I swapped these two, so now my number things are closer and I can crunch them. Or maybe the a is now closer to a terms and I can add those. All right, b times negative 52. We're just flipping it around. Negative 52 times b, which when the number's in front, we don't write the dot, we just smush them. Now d, I don't know why they did this, but addition is the quote unquote bigger operation, like it's the last thing you would do. So that is what I would assume they mean to swap here. Alex would not ask you to do this because it's vague. Like the directions do not match with what it's asking here, but to apply the commutative property of addition, I would change this into 12z plus 5a. And I could also apply the commutative property of multiplication, but I'd be swapping like z and 12 and 5 and a just with each other, and it would look silly. We try really hard to write numbers in front of variables. Like that's the colloquial math grammar rule. That some old white guy once upon a time, way back in the day, decreed this is how it shall be. Actually, wasn't that long though, like maybe 3 centuries. Now the associative property. So here, all you do is move the parentheses. You don't change the order, nothing else. You might have to put in a multiply or an add sign depending on how it looks. So here, negative 4 smushed onto 13a. That is 13 times a. So we're going to reassociate. Oh, and then it says, then simplify the expression. So these are going to do something after we reassociate. All right. So this becomes moving the parentheses over. So it's associating the negative 4 and the 13, and the a is left over outside now. But that is still being attached by multiplication. We just don't write it. Now, negative 4 times 13 is something I can crunch. I can calculate that. And that's actually, I remember it because it's a card number. So there's 13 cards in a suit, 4 suits in a deck, so it's 52, but negative. So this simplifies to negative 52 A's. Now over here, 5b plus 13 in parentheses, meaning do that first and then add 8. But all of that's addition, so I can regroup, reassociate. So now instead I will have 5b's outside the parentheses and the plus, and then the 13 plus 8. Now I want to point out that plus there makes it so this is not a distribution situation. If you didn't have the plus, then you're saying 5b times 13 plus 8, and that is a different thing than what we started with. All right, so the 13 plus 8, we can crunch that. 7 would get me to 20, and 1 more would get me 8 more, so it's 21. So 5b's plus a constant term of 21. All right, now C actually is going to require more than just the associative property. We would also need the commutative property. So I want to get the numbers up front so I can crunch them together and have the variable at the end. Now, if you're comfy in your head with just swapping that all around and doing the thing, that's fine. But I'm going to take it one step at a time just so we're all on the same page. So I'm going to reassociate. So the negative 2 is now on the outside, and I will have x times 27 inside the parentheses. Now I'm going to apply my commutative property and swap the stuff inside the parentheses. So still have -2 outside, but now inside, I'm going to have 27x. And then I'm going to reassociate so the -2 and the 27 are being considered together. So -2 times 27. And then double 27 is 40 and 14, so 54, but negative. So this one, final answer, is -54 with an x. And then D here, we got a negative number plus a negative number plus t. That's not that bad. So we're going to reassociate. And you may see me actually just like throw parentheses in there like that, just to be, all right, this is what it's going to be. It's really sloppy for board work or whatnot, but I might do it if you guys ask me a question live. All right, so we are going to move the parentheses. So it is -21 plus -49. And then the plus t after that. You need the plus, and then I put little curls on my t's so they don't look like pluses. Assuming my handwriting doesn't get totally atrocious. Some people don't like seeing plus and negative. I personally don't care, but if that bothers you, you can sneak a little set of parentheses around the negative number so it's different. But negative number plus more negative number, this is just going to get way more negative. 21 and 49 makes 70. So this gets -70. That's where this is going to end up. And then plus t. So that is what that one would simplify down to. Certainly, you do not have to write this many steps to do these, but this is just the what's going on. And a lot of you guys already have this because you've been doing it so long. All I'm doing is breaking it down and reminding you guys why it works, how it works, because it's really easy to just keep doing things by rote without thinking about it. But if one little mistake gets in there, like suddenly it's just off. And then it gets more off and more off and more off the more you keep repeating it with the mistake that you don't know is there. Whew. All right. I'm going to pause that and then we'll come do the distributive property.